Now example 5.7. Question A. Magnetic field lines show the direction at every point along which a small magnetized needle aligns at the point. Do the magnetic field lines also represent the line of force on a moving charged particle at every point? No. Because when we think about any moving charge in the magnetic field, then the force on it, that is given by the equation F, that is Q into V cross B, means the force is always perpendicular to the magnetic field. So field line, or we can say the direction of the magnetic field, in that particular direction charge will not experience the force, and therefore we can't represent the magnetic field lines as line of force. But in electric field lines, we represent electric field lines as a line of force, because when any charge Q is placed in the electric field, the force act, that is Q into E. So the force that is in the direction of the field. Therefore, you can represent it as a line of force also, but in magnetic field it is not possible. Clear to all of you? Question B. Magnetic field lines can be entirely confined within the core of a toroid, but not within a straight solenoid. Why? Because toroid, that is endless. Okay, so field lines can be confined within it. But for the straight solenoid, from the end of the solenoid, when field line come out, then it will form a closed loop. So inside it, we can't confine it. Okay. Now question C. If magnetic monopoles existed, how could the Gauss's law of magnetism be modified? So if monopole exists in the nature, then on the right hand side of the Gauss's law, we have to write mu0 into Qm. So integration B dot ds over the closed surface, that is equal to mu0 into Qm. In this way, we have to modify it, and we already discussed this thing in the theory also. Question D. Does a bar magnet exert a torque on itself due to its own field? No, it is not possible. Does one element of a current carrying wire exert a force on the other element of the same wire? Yes, it is possible if the current carrying wire is not a straight wire. If it is a loop, or if it is in any other shape, then definitely one current element exerts the force on other current element. Clear to all of you? Next, a magnetic field arises due to charges in motion. Can a system have magnetic moments even though its net charge is zero? Yes. If net charge, that is zero, then also it may have the magnetic moment, because magnetic moment arises, that is due to current loops, and current loops are formed due to motion of charges. So if net charge of the system, that is zero, but the motion of charges can produce the magnetic moment. Clear to all of you?